Well, welcome to lab. We're going to finish the review that we started during class. And if you have class this afternoon, and this is the first time you have math this morning, what you're seeing is the second part of the review. We'll do the first part in class this afternoon. So the problem we were getting about ready to start was this. This is the age problem. This is the section 2.5. John is as old as Martha. Now, 5 years ago, the sum of their ages was 50. How old are they now? Well, we want to break this down. Now, this is where the 6-step approach is really good. For the numbers problems, a lot of it you're just translating in those. And you could just translate and just come up with an answer or an equation that you can solve. But the process that we learned about in class, it's very good for this. So let's talk about what we know and what we don't know. So what do we know? Well, we know John is 4 times as old as Martha. Now, it's important to remember with the age problems, that's today. Today, John is 4 times as old as Martha. Now, we also know 5 years ago, the sum of their ages was 50. So that's what we know. We know something about John's age today. We actually know something about both of their ages 5 years ago. Maybe not terribly specific to each person, but we do know something about both of their ages 5 years ago. The sum of those ages was 50. So what's unknown? Well, we know something about both of their ages 5 years ago, but as far as their ages today, we just know something about John. We don't know anything about Martha. So Martha's age today. That's what we don't know. So we know something about both their ages 50 years ago. We know only something about John's today. We don't know anything about Martha's today. So for step 2, let M be Martha's age today. Now let's do a little translating here. And what we could do is get into our box. So the box that we use for the ages, we can have a today, let's see, that was 5 years ago. So what we do is we have time across the top and people vertically. And then we fill in these squares. or rectangles. So let's start with today. And that's what we want to do. Today, how old is Martha? Well, we don't know anything. So Martha was just M years old. Now, we do know something about John's age today. John is 4 times as old as Martha. So that's 4 times Martha's age. So we want to do the today column first. Now for the 5 years ago column, we subtract 5 from each of their ages today. So this is how old they are today. This is how old they are 5 years ago. Well, now we can put together an equation. According to the problem, 5 years ago, or that column, the sum of their ages is 50. So now we have an equation that we can solve. So combine like terms, m and 4m, or 5m, minus 5 and minus 5, minus 10, that's equal to 50. Now add 10 to both sides. Finally, divide by 5. So we get Martha is 12. Now that's Martha's age today. The distinction between today and 5 years ago is important. This is Martha's age today. Now to find John, John's age today is 4 times Martha's, or 4 times 12, or 48. And so that's how we can come up with their ages using that box technique. Now again, for parts 5 and part 6, do these answers make sense? And well, let's see. If we, for example, 5 years ago, the sum of their ages is 50. So 5 years ago, m minus 5 will be 12 minus 5, or 7. And then 4m minus 5, well, that's 48 minus 5, or 43. And if you add these up, sure enough, you get 50. So that's one way you can check to see if you've got this correct. Let's see. So perimeter problem. So the length of a rectangle is 5 inches more than the width. The perimeter is 34 inches. Find the length and width. So again, we want to break this down into knowns and unknowns. So what do we know? Well, we know something about the length. The length is 5 inches more than the width. We also know something about the perimeter. The perimeter is 34 inches. And if you want, you could throw in the perimeter formula for a rectangle. If you happen to know it. If you don't know it, you might mention that in your unknown section where, okay, I don't know, I'm going to find out what we don't know. And then in addition, I don't know how to calculate the perimeter of a rectangle. So that would be something you'd want to try to recall. So for unknown, what do we know nothing about? We know nothing about the width. They gave us something about the length, but we know absolutely nothing about the width other than it exists. So the unknown is the width. So what we're going to do, we'll give the width a variable, we'll call it x. And we can do some translating. The length is 5 inches more than the width. So there's an expression here we can translate. Really, it's sort of like a mini equation, not the equation. But here, that's your equals. 5 inches, we can just call that 5. More than, that's going to be plus. And then the width, well, we call that x. So what that says is that the length is 5 plus x. Now let's try to put together our equation. Now, if it helps, what you can do for this part is you can draw a picture also. There's the length, and there's the width. And with the rectangle, we'll have this. Perimeter, we just add the 4 sides. And we're told that's equal to 34. We could also use the formula, though. 2 times length and 2 times width. So we're told the perimeter was 34. The length, we figured that out. That's 5 plus x. And then the width is just x. So this is the equation we're going to solve. So we'll distribute 2. Two x plus 2x, 4x, subtract 10. Divide by 4. And we get 6 is equal to x. Now we want to remember x is the width. So the length, that's 5 plus x. Or 5 plus 6. Or the length is going to be 11. Now, a quick way to check this problem. We're told that the perimeter of this rectangle is 34. So what we can do if we add up these sides, do we get 34? Or we can plug them into the formula as well. And that will equal 34. Or you could check it using the formula. There's the length, there's the width, and sure enough, we get 34. And also, you know, the length is 5 more than the width. So it looks like we've got some good answers here. Questions about that? All right. So the last type of problem we looked at 2.5 was the coin problems. So let's say we have this one. So Corey has a collection of nickels, dimes, and quarters with a total value of $2.55. There are 6 more dimes than nickels and twice as many quarters as nickels. How many of each coin is there? So we want to talk about, again, knowns and unknowns. So what do we know? Well, we know the total value is $2.55. Now, what can help with these, you don't have to do this, but you can multiply the values in these types of problems by 100. So instead of dealing with dollars, you're dealing only with cents. So that means $2.55 is 255 cents. You multiply this by 100, you'll get 255. And you don't have to do this. You can leave it as decimals and everything will work out just fine. Now, we know there are 6 more dimes. And nickels. There's twice as many quarters as nickels. And again, we know the values of nickels, dimes, and quarters. For a dime, it's $0.05. Or again, you can make it into 5 cents. For a dime, $0.10. And you could leave it like this, or you can make it into 10 cents. Oh, I'm sorry, this is nickel. This is dime. And for quarter, you can make that into 25 cents. So you have nickel, dime, quarter, we know the values. And again, you can go with the decimals, or you can go with cents. The only thing is, if you go with decimals, keep it all decimal. If you go with cents, keep it all cents. So what do we not know? Well, okay, we know the values of the coins. We know the total. But we know something about the number of dimes and something about the number of quarters. We know that there's 6 more dimes than nickels. We know there's twice as many quarters than nickels. So we know something about the number of dimes, something about the number of quarters. But we know nothing about the number of nickels. That's the big mystery. So we don't know anything about the number of nickels. In step 2, we're going to give the number of nickels a variable. So let n be the number of nickels. Well, what we're going to do, we're going to set up our chart. Now with coins, we set up a particular chart where we have the number of coins and the value vertically, and then the types of coins horizontally. So nickels, dimes, and quarters. Well, the number of nickels. Well, that was just n. We didn't know, so we gave it an unknown number representation, a variable. Now for dimes. Well, 6 more dimes than nickels. So if you have the number of nickels, if you add 6 more, you'll get the number of dimes. So that means the number of dimes, n plus 6. So twice as many quarters as nickels. So if you have the number of nickels, you multiply by 2, you get the number of quarters. So that means quarters will be 2 times the number of nickels. Twice as many quarters as nickels. Now for the value, I'm going to use the cents approach. But you multiply by the value of each coin. So a nickel is 5 cents. So you take the value per coin times the number of coins. Dimes are 10 cents. Value per coin times the number of coins. Quarters are 25 cents. Value of a coin times the number of coins. So now we can come up with our equation. Now we're told that the total value is $2.55, or putting it completely into cents, 255 cents. So if we take the value of nickels plus the value of dimes plus the value of quarters, that should come out to 255 cents. At least that's the claim. So this is the equation we're going to solve. So we'll distribute the 10, distribute the 25 to get rid of the parentheses. Oh, we don't need to distribute the 25. These will just multiply together. 5n plus 10n will be 15n. Oh, and we got another 50n, so it's going to be 65n. We can subtract 60 from both sides. Divide by 65. We'll get n is equal to 30. So that's going to be the number of nickels. Now for the number of dimes, it's n plus 6. So for dimes, so there's 9 dimes. And then for quarters, that's going to be your number of quarters. Let me double check that. Hold on, that doesn't seem quite right. Oh, I'm sorry. It's nickels. That's going to be 6. So it's 2 times the number of nickels, not 2 times the number of dimes. Now, how do we know we got this right? Well, there's a check we could do. Remember, the total value is 255 cents. So we can take a look at this. There's 6 more dimes than nickels. That works out. And there's twice as many quarters as nickels. So that part works out. Well, now let's see if we calculate the values of nickels, dimes, and quarters and add those up. Do we get 255? Well, 5 times the number of nickels, 10 times the number of dimes, plus 25 times the number of quarters. And sure enough, what we're going to get is 255. So any questions about that? So those are sort of the main problems in 2.5. So in 2.6, there's basically 3 types of problems they introduce. And with those problems, there's some miscellaneous ones they have as well, where they challenge you to come up with your own kind of solution. So for consecutive integers, if you have a starting number x, the next integer is x plus 1. The next integer will be x plus 2, and so on. For even or odd, though, if your starting integer, the next one will be x plus 2, then x plus 4, x plus 6, and so on. So for consecutive integers, consecutive even or odd integers. So let's say the sum of 2 consecutive let's see, 2 consecutive integers is negative 9. So again, you could think of it in terms of knowns and unknowns. I mean, you can say, for example, what do we know? Well, we have consecutive integers. And they sum to 9. What's unknown? And again, I kind of disagree with the book on this. They say, well, the 2 numbers are unknown. We actually know something about the second integer. Because it's consecutive, it's whatever the first integer was, plus 1. So I'll kind of do both. The numbers are unknown. But really, the major unknown is the start number. If we know the start one, then we easily find the next number. We just add 1. So for step 2, let x be the start integer. So that means if x is the start, then start plus 1, which is going to be the next integer, will be x plus 1. So now we can put together an equation. The sum of these 2 integers is negative 9. And this gives us the equation we want to solve. Subtract 1 from both sides. Divide by 2. So we find out that the start integer is negative 5. To find the second integer, or the next integer, and there we go. So remember, if you have a more negativity in your number, say negative 5 is farther to the left than negative 4, that means negative 5 is smaller than negative 4. So we do have consecutive integers. We start with this one. We move 1 unit to the right, the larger number, which is negative 4. And so we have that. And if you add them up, you do get negative 9. So it looks like we've got pretty good answers. Now, for even and odd, let's say we have this. Switch just a little bit. So let's say the sum So the sum of two consecutive odd integers is negative 76. So again, what do we know? What do we not know? Well, we have consecutive odd integers. And we know that their sum is negative 76. So what do we not know? It's the integers or the numbers. But particularly, what we don't know is the start number. So that being the case, we're going to give the start number a variable. So call the start x. So when we construct our consecutive integers, for odd or even, it's x, or it's start plus 2, start plus 4, start plus 6. So the next odd integer will be start plus 2. That's just a property of odd integers. So if our start is x, well, the next integer will be x plus 2. Now we're going to add these together. And if we add these together, we get negative 76, according to the problem. So combine like terms. Subtract 2 from both sides. Divide by 2. And we get our starting integer. So negative 78, that's going to be negative 39. And that's going to be our starting integer. Now the next integer, or the second one, that's x plus 2. Or negative 37. And we can check these. I mean, they are consecutive odd integers, because if you count up, you go negative 39, negative 38, negative 37. The even number would be between, negative even number. And then if you add them up, sure enough, you're going to get negative 76. So any questions about that? So I'm going to look at two other problems from this section. Let's see. So interest problems. Let's say you have this. You're going to put money in two savings accounts. One of the accounts (6% interest). The other pays 8%. So for whatever reasons, you're putting money in two separate accounts. You're putting some in a 6% interest and another money in an 8% interest. And in this case, these are annual interest rates. So this is how much you get for leaving the money in there for a year. They'll give you 6% of whatever you invested. So if you invested $100 in this account, you're going to get $6 back, or 6%. So you have a little more information here. There's $800 more in the 6% than compared to the 8%. Now, if the total interest is $104 after a year, well then how much was invested in each of these accounts? How do we find out how much money was split up? So we're going to do some math. So one account, again, pays 6%. The other pays 8%. There is $800 more in the 6% than in the 8%. The total interest after a year is $104. So again, knowns and unknowns. So what do we know? Well, what we're interested in is, unlike the ages problem, for example, like the ages problem, we're interested in ages today, and then what were their ages in the past, or what will be their ages in the future. With the coins problem, we're interested in how many coins there are, and the value for each types of coins. Like what's the value of your nickels, the value of your dimes, the value of your quarters. For this, we're interested in two things. We're interested in the amount of money in each account and the interest earned in each account. So we think about known. What do we know? Well, as far as amount goes, there's $800 more in the 6% account than the 8%. We know that much. Now, we know something about the interest for both accounts. So we actually know something about the interest in both accounts, though it's a little vague. The total interest for both accounts is 104. But we only know, in terms of the amount of money in each account, we only know something about the 6% account. And what we know is that it has $800 more than what's in the 8% account. So what we don't know anything about at all is the amount in the 8% account. No idea. So now we're going to construct a box. Oh, first we got to come up with a variable. So we don't know anything about what's in the 8% account. So what we're going to say is this. We'll let x be the amount in the 8%. Because we don't know anything about that. And that's the first thing we want to do with step 2. So that's going to be our x. Reiterate, this is our step 2 here. So we want to give that amount a variable. Now we're also told, though, the 6% has $800 more than whatever we put into the 8% account. So that means 6%, 800 plus x. Now for the interest, when we calculate interest, we take the amount of money times the interest rate. The interest rate has to be converted to a decimal. So for the 8%, 0.08 times x, or the amount in the 8%. For the 6%, 0.06 times 800 plus x. All right. So this sets us up for step 3, coming up with our equation. We're told that the total interest is $104. So we take the amount of interest here plus the amount of interest here, we get $104. So first off, we want to distribute this 0.06. So that's going to be 48. Plus 0.06x plus 0.08x equals 104. We can combine these like terms. We're going to get 0.14x when we do. Now we can subtract 48. Let's see. $56. Divide both sides by 0.14. X, or the amount of money in the 8% account, $400. Well, that's how much in the 8%. How much is in the 6%? Well, for the 6%, it was 800 plus X. 800 plus 400, or $1,200. questions about that? So the last type of story problem to cover in this section is the triangle problem. And there's some miscellaneous ones here too you can practice on. So let's see. So one angle of a triangle measures 50 degrees more than the smallest angle, while a third angle is 3 times more than the smallest. And what they want us to do is to find all these angles. So again, what do we know? What do we not know? Now, one thing I should have mentioned in the interest problem we just did is there was something else that we hopefully know or we can remember, and that's how you calculate interest. And the interest is the principal, or how much you've invested, times the interest rate. And that's what we call simple interest. So there's a little extra bit of science that we want to know in this problem too. So what do we know? Well, one angle is 50 degrees more than the smallest. We also know a third angle is 3 times the smallest. And just like in the interest problem, I'd want to make sure the amount of interest is, well, how much is invested, or the principal times the interest rate as a decimal number. Or if you recall back to the perimeter question, you might want to remember that, well, the perimeter is 2 times length plus 2 times width for a rectangle. Here, there's another bit of science you want to remember. If you sum the angles in a triangle, they should add up to 180 degrees. So that's something you're going to want to know for this problem. Now, if you don't know it, you'd go under your unknowns and be like, what do you do with these angles? How much, hopefully that's a question you would know to ask. Or put it this way, you'd want to remember to ask that question. So here we go. This is the key point with the triangle problems. The sum of the angles is 180 degrees. Hang on to that piece of information. So what do we not know? Well, we know something about some one angle. We know something about the measure of a third angle, but there's the smallest angle. Other than we know that it exists, we know nothing about it. So that's going to be our unknown. Measure of the smallest angle. So this is what we're going to call x. So x is the measure of the smallest angle. So you can build a chart with this if you want. And it's a one-row chart. You have the angle measures. And then we have the three angles. There's our smallest, our one angle, then our third angle. Now, we didn't know anything specific about the measure of the smallest angle, so we're going to call that x. Now, for the one angle, we can do some translating, actually, to find out a little more. So the one angle is 50 degrees more than the smallest. So again, is equals 50 degrees, 50, more than is plus. And the smallest is x. So we get the one angle is 50 plus x. Any questions about that? Now for the third angle. What do we know about that third angle? Well, what we knew is that the third angle is 3 times the smallest. So again, we're going to translate. There's is. There's 3 times. There's the smallest. Or put another way, the third angle is 3x. So now we can build our equation, and we use the fact that the sine is going to be 180 degrees. We use that fact. And so this will become the equation that we're going to solve. So we can combine all the x terms, an x and 3 more x's, 5x. Subtract 50 from both sides. Divide by 5. Let's see, what does that come out to? So for our smallest angle, it'll come out at 26 degrees. So that's our smallest angle. Now, for the one angle, well, that was 50 plus the smallest. And that's going to be 76 degrees. Now for the third angle, that was 3 times the smallest. Let's see, that would be 78 degrees. Now the thing we want to do is make sure we didn't make a mistake here. So we can take these 3 angles, add them up, and do we get 180? I'll do a quick sum here real quick. Well, if you add these up, they do give you 180. And certainly this is 3 times this. This is 50 more than that. So it looks like we've got correct answers. So in the last 15 minutes, there's usually not enough time to get through the last section, but we just covered that last section. So I'll just sort of go through a few questions kind of quick. And then that'll be it for today. So let's say we have this. So this is 7.4. And we want to solve for x. Well, again, parentheses, we want to get rid of those by distributing. And the way we're going to solve for x, we solve for it just like we would with a linear equation. It's just there's 2 things. We're going to have an infinite answer, some kind of an interval, or we might get a non-existent answer, like get something kind of, oh, we're going to get infinite answers in this case. And then sometimes you get a non-existent one. If we multiply or divide by a negative number, let's kind of flip around our inequality. So we distribute to get rid of parentheses. And again, I'm just going to treat this as if it's like a linear equation. Just keeping those 2 things in mind. The kinds of answers I could get. And if I multiply or divide by a negative number, my inequality flips around. Now these we can combine. Since we're dividing by a positive 4, there's no flipping around. And so x is less than 19/4. So for our answer, what we're going to get, if we're going to give it graphically, x, you could say, represents all the numbers that. So in this case, x isn't just one unknown number, it's all the possible numbers. And we don't necessarily know them till now. It's all the numbers that are going to be smaller than 19/4. So smaller means the left side of 19/4. Bigger is going to be right. And because there's no equal to here, that means we're not including 19/4. So we put a circle there saying we want everything smaller than 19/4, but not 19/4 itself. And that would be our answer. Questions about that? So another one to do, let's say we have this. Let's say I have a compound inequality. Now we're going to try to isolate m, but we're going to isolate it in the middle. And whatever we do to cancel things around m, we have to also do to the sides. So if I want to cancel a 1, then I got to subtract 1 here, subtract 1 there. So what this says is we have m between -4 and 2. Now, because we have the equals here, this means m can equal -4, and m can equal 2. And that would be our answer. Questions about that? So let's say we have something like this. I capitalize my ors. They don't in the text. That's okay. So when we have this kind of situation, we have to solve both of the inequalities, not just one of them. We do need to solve both. So for this first one, subtract 5 from both sides. Same here. By coincidence, that doesn't always turn out that way. So we have these two results. X is less than or equal to -7. And X is greater than or equal to -3. So if x is less than -7, that's saying that x is going to be to the left of -7 on the number line. So that means x is going to be over here, and it can equal -7. So we put a dot. So x is greater than -3. So what does that mean on the number line? Well, everything that's bigger than -3, all the bigger things are to the right. And x could equal -3. So we have that. Now let me see here. That's pretty much the different types. The only other thing to mention would be this. And this will be the last problem for today. Key phrase at least. And we want to know what are the possibilities for these two integers. So if you go back to page 212, x at least, that means x greater than or equal to. X at most, that's x less than or equal to. So those are two new key phrases that to kind of keep an eye on. So what do we know? Well, again, we have consecutive integers. We know the sum is at least 583. So finally, what's unknown? Well, we don't know the two numbers. And again, this is where I differ from the book a little bit. Specifically, we don't know the starting number. Because if we know the start number, we easily find the next number. So again, let the start number be x. So if the start is x, the next number will be x plus 1. And now we can construct our inequality, because it says that the sum of these two numbers is at least 583. So this plus the next one is at least, let me double check something. Oh, I'm sorry, at least is the other way. At least 583. So it could be 583 or something bigger. So this gives us the equation to solve. Finding like terms. Subtract 1 from both sides. Divide by 2. And since it's a positive 2, nothing flips around. So that means x is at least, that's 582 divided by 2. $291. So to find our next number, that's x plus 1, is greater than or equal to 291. Oh, sorry, we don't need to. This is going to give us what we want. So x is going to be 291 or greater. So that means if x was equal to 291, what this is saying, then x plus 2, or x plus 1, would be 292. But if we choose x to be any number bigger than 291, then if we take the next integer and add it, we're going to get something that's 583 or bigger. And you can see that here if you add these. You'll get 583. So as long as the first number is at least 291, the second number will be, say, the next number after that. The sum of those two numbers will always be equal to or bigger 583. So that's it. I hope that helped give a little bit of a review. Again, a review is not comprehensive. There are some, like for example, in 2.7, you could get problems where there are no solution. So keep an eye out for stuff like that. But I hope that gives you a good kickstart to study for the exam this weekend. If you have any questions, let me know. Other than that, have a wonderful day and a wonderful weekend. And we'll be testing on Monday. So if you're in the morning class, we'll meet up at the regular time, and I'll give you the access code. For the afternoon class, we'll meet up at the regular time, and I'll give you that access code. And other than that, see you next week, unless I see you for office hours.